Okay, so we have a car, we know the power output of that car, and we want to know how much force it is exerting when it drives at a particular speed. Yes?
What chapter or what is this?
5. So. Just to start with, I'm going to list down what we've got. Power is some randomly determined number, specifically given in horsepowers. Next is current velocity, and we've been asked for the force that the engine can exert. Oh, estimate the total frictional force. So, power, velocity, and force. To quickly give a illustration of why friction matters here we have a car, and if a car is driving at constant velocity, the engine is exerting some amount of force forwards via the wheels. Meanwhile, the force of friction will be acting backwards. And if you're driving at constant speed, what's the relationship between these two things? They add up to 0, yes, because they are equal and opposite. So if we can figure out the force the engine exerts, we can figure out what the force of friction should be. Does that track so far?
Is the car like, so the car's moving?
Yes. Car's moving at speed. And because if you're at constant speed, and we are, this is the one speed, whatever speed you're given is the one unchanging speed for this question. In that moment, the force of friction backwards should be the same as the force from the engine forwards. And so if we can find a force engine, we can indirectly find force of friction. And one of the power formulas, there's 2 of them, actually references the force being used to push something forwards times the speed at which that force is causing it to move. So this formula's perspective, engine power equals engine force times speed of the car.
Okay.
So this is ultimately what you'd be after, because if you find the engine's force, you have indirectly found the force of friction. The only other hiccup getting there is converting horsepowers into watts first. Does that feel better? Okay. Yes?
And we will have our formula sheet for the test.
You will. The formula sheet is usable by you on every assignment for this class. As is your calculator. The only tool you won't have access to in the test is your classmates and the internet. Speaking of, make sure your calculator is not a cell phone. Okay, just one sec. Okay. How's everyone doing? Write that down, it'll be on the test. Speaking of the test, that's next week. So let's, not to make anyone panic, let's review the calendar and then all the test study information that I would recommend for you. Today is Friday, September 29th. Our main goals for today are reviewing everything we've recently done, briefly reviewing the entire semester thus far, and making sure everyone feels comfortable for the test next week. Said test takes place over the entire week from Monday the 2nd through Friday the 6th, meaning that you take it during lab and therefore the test is being given over next week, but you only have to come in to take it once. You'll report to lab when you normally would, and you will take a 1-hour test within a 3-hour time slot, so that you don't have to rush and cram it in during lecture. So, no normal lab, show up for lab, but come here and you'll take the test. Lecture next week will be for test review purposes mostly, so if you have any questions or issues while studying for the test, we will review those things together here in class. Please bring any and all questions so we can talk about them together. As odds are, if you're struggling with something, someone else is too, and I want to help everyone once. Yes?
So wait, we come here for lab?
Yes.
Okay.
So next week, rather than going to 126, you'll come here and take the test. And you can also take the test during any of the 4 lab slots. You can just show up either Monday, Tuesday, Wednesday, or Friday. Thursday doesn't exist. Thursday is a myth. Any of those other 4 days, you can take the test. And the proctors will be the same. Dr. Edwards does Monday, Tuesday. I do Wednesday, Friday. And you can show up any of those days. You could show up Monday if you just want it over with. You could show up Friday if you want all week to study. You don't really have to let me know which one you're coming to, because I ask for people to tell me for lab so that I can guarantee there's enough stools in the room, but there's plenty of chairs in here. So as long as not everyone shows up on Friday, it'll be fine. And again, lecture next week is for review purposes. So technically, if you take the test on Monday, lecture the rest of the week is for a test you finished. So you could take the week off if you wanted to. I do recommend coming, especially if you haven't taken the test yet, but nice little mini vacation before fall break, if you take the test early. In terms of materials for studying for the test, I recommend you do homework chapters 1 through 5, and also quizzes chapter 1 through 5 on WebAssign. Looking at those homework questions is something we can do in class on our review days. And once again, there is both a practice test on on Brightspace. There's too many online things. And I've also already uploaded an answer key for that practice test where all the answers are in red and all my work is there too. So this is a very good tool to help study. It is not an exact match for the test. The questions won't be exactly the same, but all the right concepts are there. And all the right types of math that you need to do are there. I wrote this specifically after writing the test itself to make sure that everything matched up as best as it could. Word of caution, the practice test is both longer and more difficult than the test itself, because I'd rather you struggle here than there. When you come in to take the test, it's designed to take 1 hour, but you'll have up to the 3 hours of lab time. And there is 105 points graded out of 100 points. So rather than a bonus question that you may or may not get, there's just more points than you need built in. 9 questions, 7 of which are math focused, 2 of which are concept short answer focused. Each question tells you how many points it's worth. So if it's worth a small amount of points, maybe don't stress about it so much. If it's worth a lot of points, that means it's a trickier one, and that means it's okay if it takes you a second. And the only way to get a 0 on my tests is to leave them blank. You get get points for everything you write. Even if I ask you for math, you get points for writing a paragraph about what you understand is going on. As long as you give everything an honest shot and answer something for everything, like you can get a 50 without trying very hard. You can get an A without even getting all the math totally correct. Like you can make mistakes and still get an A. Was that a question a second ago? Any small hand movement triggers that response in my brain, sorry. How you guys feel? Yes.
And are all the labs just at the same time?
Yes, whatever day you have lab or whatever day you come for the test, it starts at 1:30 and officially ends at 4:30. You can leave when you finish the test. Again, you have up to 3 hours. It's designed to only take one, but I just give everyone up to the 3 since I'm gonna be here anyway. You're also encouraged to ask questions because I want to make sure at an absolute minimum everyone understands what they're being asked for. So if you're unsure about something, you're allowed to ask. I encourage that. You also have your formula sheet and your calculator. You can write all over the formula sheet. The only things I wouldn't say to write out are like answers to fully worked questions, and don't write out, paragraphs for every law of motion. I would like you to be able to place them from memory. You don't have to write them from memory, you have to be able to identify them from memory. And again, no internet, no cell phones. Make sure your calculator isn't Wi-Fi enabled. But make sure it does have sine, cosine, tangent buttons. I also usually get asked when students can expect their grades. Since the test will be administered over next week, I will then be spending the weekend grading it. Monday's fall break, so no class that day. Also no lab at all that following week since school doesn't meet these 2 days, so just no lab. So that's another kind of mini vacation. I plan on having the tests fully graded and back in your hands Wednesday at the earliest and Friday at the latest, because midterm grades go out Friday morning. So I have to have them done by Friday morning. So they'll be in your hands by then. Once I give it to you, it is yours. You may keep it. You can compare it to the answer key that I show you in class, and you can keep it to study for the final at the end of the semester. I will just spend whatever day I can them back going over my answer key so everyone understands how the test goes and what I was looking for. And then midterm scores go out on October 13th. Now, frustratingly, midterm scores are just S for passing and then D or F. So they're not very informative. So when midterms go out, if you want to know your actual current average, I will happily tell you that. How you guys feel? Entering any test territory, especially the first test in my classes, I find that my students are all often nervous. Which is fair, physics is hard. But I promise I have done my best to devise this system and write the test in such a way that it is, I promise, doable. I promise that I have not done anything to try to trick you or make things harder for you. I want you guys to succeed. I'm going to do everything I can to make that happen. And even then, if you just have a bad day, which again, I'm doing my best to make sure that doesn't happen, the course is weighted in such a way that no one assignment, no one test will ever tank your grade in here. There's 2 tests, partially for that reason. So if you just have a bad day, The other one can kind of mitigate that. And we've got all week, up to a week, to make sure you're ready. Again, I'm attempting to say all these things as a comfort. And you'll have a professor up here the entire time you're taking it to make sure that you understand what's going on. All that said, I do want to spend today doing some review stuff. During test review time, I always open the floor up to anyone with any questions about practice tests or homeworks and things like that. Today specifically, I also have prepared at least one more pre-written example of mine to just work on the last couple of concepts we did on Wednesday. And I also want to look at the list of concepts so that you've at least heard out loud from me all the things that will be on the test. Any specific questions from you guys before we start working on those things? Yes?
So is weight just force of gravity?
Yes, weight is force of gravity. They are synonyms. And how do you calculate force of gravity?
Mass times gravity.
Yep, mass times negative 9.8. So if I ever ask you how to calculate weight, this is your answer. If I ask you for weight and you write just M or just G, I will be sad. You'll get partial credit, but I will be sad. What's in your minds at this particular moment? All right. First thing I want to do, last time we worked on EPE and also introduced power, so I would like to briefly do just a little bit more practice work for those two things. I figured out one example that has both of them. Here we have two different baseball launching machines. One of them is a robot pitching arm, and the other is a spring-loaded cannon, a lot like the ones we have in lab. And they are both going to launch 150-gram baseballs, and we need to figure out which one is going to be more effective based on its technical specs. The pitching arm is stated to have a power output of 1,500 watts, and it's going to take it a time of half a second from being loaded to wind up and throw the ball. So kind of like how a human would go through a motion, something like this, and it takes like half a second. That's also the time it takes the robot to wind up and throw. And then separately, we've got a very poorly drawn spring cannon. This cannon's spring constant is 200 newtons per meter, and when you load it, the spring is going to compress a distance of 10 centimeters. We need to figure out from these given pieces of information the speed that either machine is going to launch a 150-gram baseball. Any thoughts on how we can get launch speed from either machine with the information we can get? Very good. Well, power will definitely help. We've been given the robot's power output, which can tell us a couple different things. We know its power output is 1500 watts. We've got two formulas for power. One is work over time. The other is force times velocity. Now we know the time it takes it to pitch. We do want the launch speed. Like, this is what we want to figure out. So we need to figure out some way to end up at V. Trouble is, we don't have the force it exerts yet, so we have to figure a couple more things out before we can get from here to here. But we do have its power. We also have the time it takes to launch. So we could figure out the work the arm does, which would be the energy the arm uses up upon pitching a ball. And when you do work, when you use up energy, it has to go somewhere, right? So however much work the arm is doing, where is that energy going to go? Into the baseball in what form? Kinetic energy. So, however much work the arm does should ideally be the kinetic energy the baseball gains. And if we know kinetic energy, like we can estimate kinetic energy by figuring out the work the arm does, since we know the mass of the ball, we can use the kinetic energy formula to figure out the speed the arm would throw it at. To demonstrate, we're going to use this formula to find the work done by the arm. 1500 is going to equal that work over half a second. Multiply both sides by 0.05, and that means that the arm is going to do 750 joules of work. Now, in an ideal setting, if we're ignoring friction and other pesky things like it, all of those 750 joules are going to become kinetic energy in the baseball. And so if we assume that, if we assume maximum transmission of energy from work done into the ball, we can figure out, oh, we know the ball's mass, excuse me. We can figure out the speed the ball would have if it had 750 joules of kinetic energy. This would again be the pitching arm's maximum throw speed in ideal conditions. Bless you. Square root. That would make V equal to square root of 750 over 1/2 of 0.15. Why did I write 0.15 instead of 150?
It's in grams.
Yep. And what unit do we want it to be in? And my math indicates a final maximum pitch speed of 100 meters per second, which is about a third to a fourth the speed of sound. This is a very effective pitching arm. This thing would not be legal in regulation baseball. So, the arm is very good. Whoever built it should be very proud of themselves, and no human should ever stand in the way of that baseball. Let's see how the spring cannon compares. For the spring cannon, we know its spring constant and how much it's compressed in order to fire a baseball. What two formulas utilize those two pieces of information? Very good. And there is a second option. The formula for spring force. But my last class asked about this formula, and in the attempt for me to be as non-vague as possible, I've written the test coincidentally in a way that doesn't use this formula, so I get to try to settle minds and keep students from doing the wrong thing on tests, and the practice test is written the same way. You won't need this formula. If you see K on the test, this is where your mind should go. In the interest of giving as accurate information as I can. So, we have enough information here to figure out how much EPE the spring will possess before the ball is fired. After the ball is fired, where's that EPE going to go? Kinetic energy in the ball again. Conservation of energy. So all that coiled up energy will become KE in the ball, kind of like how the work the robot arm did became KE in the ball. And so, via kinetic energy again, we can figure out how fast the ball should be moving after this process. So the EPE formula, 1/2 times our spring constant times our compression squared. Again, we want meters instead of centimeters, so I've plugged in 0.10 and make sure that only the 0.10 is what's getting squared. On the KE side, we've got 1/2 times the mass of the ball times its launch speed squared. And please correct me if your math disagrees. My math gives a launch speed of about 3.6 meters per second. So I think we have a clear winner. Cannon might do better with a tougher spring. Yes.
So for problems like this, unless it says otherwise, do we assume that there's no energy loss?
Yes. Unless indicated, you can assume ideal conversions. I will tell you if friction matters. We have not really worked cases where it has yet, and I don't think I wrote a test question where it does. And I'm trying to be as not vague as possible. There is one question where friction is present and doing work, but that is what the question is about. The question tells you that something is moving at constant speed, therefore friction is acting to keep it at constant speed. So wherever it matters, I bring it up. Wherever it doesn't matter, I don't mention it, therefore you may elect to ignore it. answer the question? Okay. How's this one feel? How do you feel about chapter 5 overall? Good to see. I hope chapter 5 wasn't bad, because after the test is done, chapter 6 is going to pick up right where it left off. So don't throw your notes out, ever. Now, that is again up to all the information that'll be on the test. We stopped learning new things on Wednesday, and so I'm not going to introduce anything new until the test is over. The only exception to that would be if you show up on review day and no one distracts me with questions, I might start rambling about something that wouldn't be on the test. So new information, but not something to be tested on. Bring questions, keep me distracted next week. What was I doing? What I'd like to do now, and this is the last thing I have prepared, is look again at this list of concepts, make sure I have told you aloud everything that will be present and what you have to know about them. This is the list of things you see when you click on test 1 itself. So click on the tab, you get this list. Within the tab is the practice test and its answer key. You don't see everything that's got a blocked out eye here, because those are old versions that you don't need. So the tab itself, this is a list of everything from the start of the course to the end. There's like 20 things on this list. That does not mean there are 20 questions. This is like the broadest list of topics, and most questions will involve 2 or 3 of these things, because they all feed into each other. But to review, the start of the course, we began with unit conversions, so you do have to be able to do those. There's at least one question on the practice test that is very direct unit conversion practice. So, gotta be able to do those. Then we started talking about vectors. If something's a vector, we care about its direction, and we also care what axis it's in. So do not forget to note those things. First 3 vectors were displacement, velocity, and acceleration, and the formulas we used to talk about them were those first 4 that we learned about, featured prominently on your formula sheet next to a movie poster. So don't forget them. Don't forget how they're used either. You look at those 4 formulas and know each of their functions. We use those formulas to talk about both 1-dimensional and 2-dimensional motion. 1D is just back and forth in a straight line, the most basic type of motion. You can't really have 0D motion. And then 2D motion is 2 axes at once. The 2 main cases where we looked at 2D motion were projectile motion, which an object is a projectile if it is falling. This includes dropping things straight down, and it also includes any example that involves launching something off of a cliff or a building, or just throwing it into the air in general. So that genre of projectile motion questions, where can you look at the motion in each axis separately? You do have to examine the 2 axes separately. So if you haven't noted that in your notes somewhere, make sure to keep that in your brains. If something is a projectile, what is its acceleration by definition? That would be its x acceleration. Yep, its y acceleration is negative 9.8 by definition. If you are a projectile, this is true automatically. I will tell you if something is a projectile. Namely, though, if it's moving through the air and I don't tell you it's flying, it's a projectile. The other type of 2D motion we did was vector addition, the sorts of stuff where you have vectors possibly pointing in more than one axis at once, and you have to add them together, x with x, y with y, and likely do some trig, either by dividing vectors up before you add them, or figuring out the magnitude direction of your united final sum vector. So there's trig on the test, if I haven't said that out loud yet. Again, make sure your non-phone calculator has sine, cosine, tangent buttons. That was chapter 3, which did involve the acceleration of gravity, but once again, that is distinct from the force of gravity. Force of gravity is m times g, acceleration of gravity is just g. If I ask you how to calculate weight, please tell me m times g. Weight is a force, which segued us into chapter 4, where we talked about various types of force and the laws of motion. Again, you have to be able to pick the laws of motion out of a lineup. The practice test asks you to write them because, again, the practice test is harder than the test by design. In examining forces, you need to understand that net force is what causes acceleration. The definition of net force is every force present acting on something added together. That is just the formula. Take all the forces, add them together, and that is sigma F. Free body diagram is just a fancy way of saying a drawing with arrows for all the forces acting on something. You will have to make at least one, but if forces are involved, it's good to make one even if I don't ask you for one. Helps keep the visual, again, I'm a visual person, so I automatically try to draw pictures if one is not given. It's just good to keep all the forces straight and keep their axes straight. Types of force we studied include a force of gravity, which again is a synonym to weight, tension, and how a pulley can change the direction of tension, but it's still inwards on both ends. Normal force, referring to how surfaces act perpendicularly out of themselves, and both types of friction. All those forces can be present on something, and they all contribute to net force. There's also that word inclines there, by which I mean referring to the fact that on an incline, normal force is no longer equal and opposite to gravity. You do have to note that at least once on the test. Now, the way that you would find normal force in this scenario, I'm going to draw a new triangle by dragging gravity over here, making them tip to tail. The relationship between gravity and normal force in this type of question is that the angle between them is the same as the angle of the slope. I'm not just writing theta here twice because theta is just what you write as an angle. I'm writing theta here twice because it's the same theta. You may write these two pictures in conjunction with each other on your formula sheet. Specifically, in this new triangle, gravity is the hypotenuse. It is not a leg alongside the normal force. It is the hypotenuse. Normal force is a leg, and it is perpendicular to the whatever force is currently acting along the slope, since the slope and normal force are perpendicular to each other. So gravity is the hypotenuse of this new weird triangle every single time. That was all the information up to chapter 4. Questions so far? Yes.
Relative velocity being tested on.
No. the last three things are what we've done over the last week in chapter 5, work, the three forms of energy that we talked about, and also power. So, the stuff we did today and over the past week. How do you guys feel? Question?
Is there an calculation for tension, or is that just the force?
There's not an equation for tension, it's just the force that a rope exerts when it's being pulled on. So, if there's a rope in a question, and that's the sort of thing I would provide a picture for to make it clear, then there would be tension present. You know what, I can show you a practice test question.
But it's just the name of the force.
Yeah, it's just the name for the force a rope exerts, so it's just the name. Where's my cursor? There we go. Practice test. I think there's two questions here that involve tension. This is a different version of the pulley thing that we looked at. And separately, there's also two ropes holding up a flower pot. Tension is only, well, yeah, tension is only present if there's a rope, and it's really just a name for the force the rope exerts. That's all. Question?
Yes. Is there only GPE when something is hanging, or could there be like GPE when something's like in the air?
There is GPE as long as an object is above some other point. As long as something has a height that you can define, it has GPE in comparison to the lower part of that height. So, whether it's in the air or on a shelf, if it has a measurable H compared to some lower elevation, there's some GPE present. That said, H is still relative, because you could say this box has no GPE relative to the cliff that it's on. So you always got to make sure to define H in terms of what it's from to what it's to. Again, I have no GPE if you consider 0 to be the floor. I have a ton of GPE if you consider 0 to be Earth's core. So H is unfortunately relative. So pictures are useful, always define your system, both in terms of positive and negative and what your 0 point is. If a system can be defined in more than one way, like again, you could decide this is 0 or this is 0, I will count you correct as long as you pick one and stick with it and do it correctly. If there's more than one way to get a correct answer, I make sure to give you the points for it as long as you pick that method and do it correctly. There is usually more than one specific way to get from point A to B in here. I do not penalize you for being creative. Anything else on your minds right now? All right. It's Friday and tests are blank, so let's call it here for today. Again, we will be spending class time next week studying. So if you do take the test Monday, we still have lecture next week if you have any questions. Also, email me questions as you're studying. I will answer them, either directly through email or through the web assignment. Ask your teacher thing if you're working on homework. Let me know anything you need. Have a nice weekend. Your homework assignment is rest, because tests are stressful.